Okay, let's get started. Chapter 5.5. In this section, we are going to study finding derivatives and integrations for exponential functions other than the base e. Um, Remember in early sections 5.1, 2, and 3, 5.1, 2, and 4, we learned about finding derivatives with base e. So that means we had um, derivative of e to the power x, that is nothing but e to the x, and we had the derivative of ln x, natural log function, that is 1 over x. Then we had, under the integration, we had the integration of e to the x is of course e to the x plus arbitrary constant. And finally, we had the antiderivative or integration of 1 over x, that is nothing but ln absolute x plus arbitrary constant. So you studied about these things in earlier sections. But here we are going to do the same thing. But the thing is now, for base e, we are going to use other numbers. Okay? So to do that, we need to know some properties of exponential functions other than the base e. So this is one of those properties. Any exponential function a to the power x could be written as in terms of base e, which is e to the power ln of that number a, then multiply this guy by x. Okay, so this property says that you could change any base e into base e by using this relationship. Okay. Now, one more property. Logarithmic function with base a of x could be written as 1 over natural log of that base a times natural log of x. This property says that you could write any log function with base a to ln x. Okay, so these are the two basic properties now we are going to use here to find the integration and differentiations dealing with base other than e. Okay, so let's move on and look at some other properties. This is not new, you studied in high school, right? If you have this relationship, if you know any exponential function ax is equals to y, then this is nothing but equivalent to write in terms of log, which is x is equal log with base a of y. Okay. Now, property number 2 says for any real number a to the power log with that base a, x is all the time equals to x. This is true for any x which is positive. Okay, a to the power log ax is always x. And also the third property says that log of any exponential a to the x with base a is equals to x for all x. This is true for even for a negative number as well. Okay, so this is another property of log. right? We're saying this, you could solve the given problem for x. Solve the following equations. Your task is to get rid of, base 3 and find x. Okay, so this is easy problem, Um, this is 3 to the power x. You could think of 2 to the 243. Can you write 243 in terms of base 3? Another word, can I write 3 to the power something which is equals to 2 to the power 243? Yes, 3 to the power 3 is 27, 3 to the power 4 is 81, and 3 to the power 5 is um, 243, right? So this is easy. You could cancel both sides 3, and this will give you x is 5. But for the second one, you could use this property. So this property says log 2x equals negative 16 could be written as what? If you replace y by x and a by 2 and y by x, you will get what? This is nothing but x is equals to the power negative 16, right? Okay, so in this way you could find x answers. Now let's move on to the derivatives. So earlier I saw you, you know, you have the derivatives with base a, but now you have the derivative with base other number, right? A. So the derivative of a to the power x is nothing but a to the power x, like e to the power x, but you see some extra factor here, that is ln a. So hereafter, if you see any derivative with the power x and base a, that is nothing but equals to a to the power x times ln a, or ln a times a to the power x. If you see other variable than x, but if you want to find the derivative with respect to x, so this is nothing but chain rule, right? So inside function a to the power u, derivative with respect to u is a to the power u times ln a, but you need to take the derivative of inside function u with respect to x, right? So that is du over dx. Okay, so the next one is the derivative of log ax is 1 over x, but you see a factor, extra factor ln a here. Okay, again, the derivative of log a, some other variable u with respect to x is 1 over u times ln a and du over dx. Okay, so these two are basically coming from chain rule. This chain rule, this and this. Okay, these two are chain rule. You see the variable u. Okay, so now by using all four properties, let us do this problem. What is the derivative of 3 to the power x? Now remember, if you compare the first one with this, a is now 3, right? So y prime, the derivative of y is nothing but 3 to the power x, correct? But you have to write ln of 3 with the factor. Okay. Now the second one, you could think of using u substitution. You could think of this like u. Okay. So this is nothing but y prime is the derivative of 2 to the power u with respect to u times du over dx. Yes, I'm using chain rule. So we know now by property number 2, The derivative of 2 to the power u with respect to u is 2 to the power u but times ln 2. Then inside function u derivative, I know u is 3x, so the derivative of 3x is simply 3, right? So our answer is there 2 to the power u was 3x, so 2 to the power 3x times ln 2 times 3. Remember, when you do the problem with variable x, you have to get back to that variable x when you use substitution, right? You have to go back and plug in the values. Okay, so this is by chain rule. Problem number 3. Let me do somewhere here. Problem was y is equal log square root x over x plus 3. Now you could use the log property to do this problem. Remember, log a over b is log a minus log b, right? If you don't see any base here, the default value is 10, right? Log means log 10. So by using log property, log a over b property, I could rewrite this as log 10 of square root x subtract log 10 of x plus 3, right? Using log property. Now we all know square root x is nothing but x to the power half, right? This is log 10 of x plus 3. So by using again log property, you could pull half in front of the log function. So this is half times log 10 x, then subtract log 10 of x plus 3. This is y, right? The question is finding the derivative of now these two functions. Okay, so let's do first part by using property number 3 here, log property with the derivatives. I could write this is half times. Therefore, I'm finding the y prime, okay? The derivative of this. The derivative of log 10x is 1 over x times 1 over ln 10 by using property 3. Then this one, think this as like u. So use chain rule with u substitution. So if this is u, this is like a ln u base 10, right? So there is nothing but 1 over u times ln 10. But remember, chain rule, you need to take the derivative all the time with respect to x. This will be 1 over, let me write down the constant part first, 2 times ln 10, and the variable, which is x. Then, what is du over dx? My u was x plus 3, right? Therefore, du over dx is just 1. Okay, so that's going to be 1 over u times 1 over ln 10 times du over dx is just 1. Now go back and replace u by the actual variable value x plus 3. Therefore, answer is 1 over 2 times ln 10 x and subtract 1 over u was x plus 3 times 1 over ln 10, right? So that's the answer. Okay, so if you see log a over b inside the log, if you see the division, then you have to use the log property. So I use the property log a over b is equals log a subtract log b. Then split them into 2, then use some log properties, and then find the derivative separately for both the functions. Okay, that is there. Here, formula for integration of a to the x. The integration or antiderivative of a to the x is nothing but a to the x, but you see the factor 1 over ln a plus arbitrary constant. That is super easy. If you look at this problem, a is now 3, right? Simply replace a by 3 there. So you will get 1 over ln 3 times 3 to the power x plus constant. Okay, you need to practice, a little bit to be familiar with it. Okay, that is there. Now we have two more set of derivative. This is the derivative of x to the n. N could be any real number, could be negative as well. So the derivative of x to the power n is n times xn minus 1. So if you see other variable u, then derivative of u to the power n with respect to x is n u to the power n minus 1 times inside function u derivative, which is du over dx. Okay. Now the derivative of e to the power e is 0 because it's all constant. Derivative of constant is 0. The second one, e to the power x derivative of e to the power x, we know that is constant. First one is constant rule. The second one we call as exponential rule. The third one is power rule because power is here, which is constant. Okay, so these are the three different scenarios you see when you find the derivative involved with exponential. Okay. Now, this problem, could you find the derivative of y using logarithmic differentiation? Logarithmic differentiation means you have to take log both sides before getting into the derivative. So you could take both sides natural log ln. Take both sides ln. Then remember, question was finding y prime, right? So take the derivative with respect to x both sides. Remember, you are taking the derivative with respect to x, but this is, you see some other variable, so you have to use the chain rule. So the derivative of ln y with respect to y is 1 over y. Okay, so you need to take the derivative of ln y with respect to x, means 1 over y times dy over dx, right, using chain rule. That is the derivative of ln y. The derivative of x times ln x, use the product rule, kf times g prime formula you learned. So the derivative of x times ln x is x times the derivative of ln x plus ln x times the derivative of x using what? Using the product rule. Now this will be x times the derivative of ln x with respect to x is 1 over x plus ln x, the derivative of x with respect to itself x is 1. So if you simplify, you will get this is gone, you will get simply 1 plus ln x. That side you have 1 over y times dy over dx. Remember, you're finding dy over dx, right? So you have to solve this equation for dy over dx. In other words, simply move y to the right side. So that means dy over dx will be y times 1 plus ln x, right? But what was y? Y was at the beginning they have given y is x to the power x. So go back and replace y by x to the power x. This is the derivative of y. In other words, dy over dx. Okay, yeah. So both the side you have to take ln if the question is finding logarithmic differentiation. So use both side ln, then take the derivative with respect to x. So you need to use the chain rule somewhere. Okay. Now this is one basic property. A limit function of 1 plus 1 over x to the power x when x goes to infinity is nothing but a value e. Okay, we all know e is a number, irrational number, which is equals to approximately 2.71. Yes. So there is one more property. Limit function of x, 1 plus a over x to the power x. A could be any real number, could be even negative. So this is nothing but e to the power a. So this formula says, suppose if you see like this, limit x goes to infinity of, say you see here 2, like that. Now this is nothing but e to the power 2. Okay. So these are the things now you have to look for in 5.5, finding integration and derivative with the base other than e. So basically we use these two, conversions in terms of ln x and e to the power x. And practice about these properties, okay? So do some textbook problems from do some problems from the textbook in web design. Okay, for 5.5.